Yesterday we have seen permutations and combinations. In the introductory part we have seen the fundamental theorem on arithmetic, or rather we can also call it as principle on counting. Okay, now let us just review what we have seen yesterday in the PPTs, previous PPTs. First PPT, and if you see the definition we have seen in that one, what is a point to be noted there? And we have seen that whenever you have that multiplication, when it should be multiplied, if you see the note there, please note. So in that note, if you see the and stands for into. That into is nothing but multiplication, and multiplication is taken for intersection, and or stands for, or R stands for plus, and that plus stands for union. That is a summary of the previous definition. Okay, now let us today see the permutation. What is the permutation? Go to the sixth slide. Just wait, previous slide. So in the doubts of last class, and yesterday one girl asked about this, sum of all or digit numbers formed by taking the given n digits including 0. I will explain it in the middle, and just for the sake of the introductory part, I'm giving you this. Let us discuss this, the formula, after 15 minutes. Okay, now let us start with this one. For the permutation, the dictionary meaning of this, it is nothing but the arrangement. Arrangement of what? Arrangement of things or objects or whatever it is. And if you arrange the things or objects by taking sum means SOME, sum or all at a time, is nothing but a permutation. So if you see like ABCD, if you take two letters at a time, and if you arrange them, two letters can be written like this, AB, and AB can be written as BA. This is AC, can be written as CA. This is AD, can be written as DA. This is BC, can be written as CB. This is BD, can be written as DB, and this is CD, can be written as DC. Now these many different arrangements we can make by taking two at a time from ABCD. Similarly, if you take 1, 2, 3, 4. 1, 2, 3, 4. How many two-digit numbers that can be formed using 1, 2, 3, 4? You can understand it is 1, 2, 2, 1, 1, 3, 3, 1, 1, 4, 4, 1, 2, 3, 3, 2, 2, 4, 4, 2, 3, 4, 4, 3, like this. So you can see the different number of arrangements that can be done. So what is the important thing to be noted in a permutation arrangement? In the permutation, whenever you are choosing two things, AB, here also 1, 2, here like 3, 4, whenever you are choosing the things, the order of things is also to be taken into consideration for a permutation. So the permutation involves in the consideration of order of things also. So the important thing to be noted in a permutation is order of things is to be considered. Should not forget it. Very important point, because later in the combination we will see the difference between a permutation and combination basing on this only. So wherever the order of things is to be considered, therever you have to apply a permutation. So here AB is written as BA. Here 1, 2 is written as 2, 1. 2, 3 is written as 3, 2. Clearly in this case, of course, the numerical value differs, because it is 23, it is 32. There is numerical value differs. So in this case, definitely whenever you come across the arrangement of digits, unless and until it is specified, you have to consider the order of things also in case of the arrangement of digits. But if you see this one, it is clear that 12 different from 21, 13 different from 31, and 14 different from 41, 34 different from 43, and you can clearly understand this. But this can also be questioned like this: how many two-digit numbers that can be formed from 1, 2, 3, 4? How many two-digit numbers that can be formed from 1, 2, 3, 4, in which the digits are present in the increasing order of magnitude. The digits are present in increasing order of magnitude. Then what happens? 1, 2 we need. We don't need 2, 1. 1, 3 we need, because it is an increasing order of magnitude. We don't need 3, 1. 1, 4 we need. 4, 1 not needed. 2, 3 we need. 3, 2 not needed. 2, 4, 4, 2 not needed. 3, 4 needed, but 4, 3 not needed. So the same question can be altered by not considering the order of the things. So understand, wherever we will discuss it in the combinations again. So what is the primary thing that is to be observed in a permutation? The order of things is always to be considered after choosing the things. Like AB taken, immediately it is rearranged as BA. Wherever it is not necessary, like 1, 2 is not to be written as 2, 1, according to the question you have to proceed. So for this permutation, now we are going to derive the formula for NPR. NPR can also be written as P of N comma R. NPR can also be written as P of N comma R. What does it mean? Permutation of N things, N dissimilar things, by taking R at a time. Permutation of N dissimilar things by taking R at a time. It can be denoted like this, and it can also be written like this. So, and its formula we are going to derive now. That is, we have seen yesterday in the principle of counting, whenever we are making the operations, we have considered the operations as different boxes or different blank places, and we have filled these blank places with different operations, and we have derived the final answer. Similarly, in this case also, you have N things in your hand and R things are to be taken. As we have seen ABCD, in ABCD we have taken ABBA. How many things are taken? 2 things are taken. So this is, here N is 4. N is 4 and R is 2. Like that. So in each of the arrangement, how many blank places do you have? In each of the arrangement, you have 2 blank places. Similarly, for N things, R things are to be taken. Then R things, for R things, how many blank places will be there? And you will have R blank places. This is first, this is second, this is third, this is R minus 1th, and this is Rth blank place. Now, let us see. First blank place can be filled with N things in how many different ways? First thing can be written, second thing can be written, third thing can be written, and so on. Nth thing can be written. Okay, now one thing is already filled. Understand, this is permutation stands for without repetition. With repetition, what will it be? We will see. Without repetition. Understand it, please. Without repetition. So, N things can be filled in the first blank place in N different ways. Because one thing is already filled, there will be remaining only N minus 1 things. And for the third blank place, there will be remaining only N minus 2 things. And so on. You can see, if it is 3, it is 2. If it is 2, it is 1. If it is R minus 1, it will be N minus of R minus 2. That is N minus R plus 2. And it will be N minus of R minus 1, which will be N minus R plus 1. So here also, it is simply based on principle of counting. That's what you have to understand. What is the principle of counting? First operation can be performed in N different ways. Second operation can be performed in N minus 1 different ways. Third operation can be performed in N minus 2 different ways. And so on. Rth operation can be performed in N minus of R plus 1 different ways. So all these operations, one after the other or simultaneously, can be performed in N into N minus 1 and N minus 2, so on into N minus R plus 1 different ways. So you have to multiply this because these are all to be performed simultaneously or one after the other. Now, for the sake of convenience, what we do, you can observe that these are in the each term is reduced by 1. That is, these are in the descending order. So what we do, we want to make it a factorial. You know the meaning of factorial. So we will multiply this total product with the next term. The next term to this is n minus r, that is minus 1, and next term to this is n minus r minus 1, and so on. To complete the factorial, we multiply with this term and we divide with the same term. It is just to complete the factorial. Now, if you read the numerator, it is 1 into 2 into 3 into so on into n minus 2 into n minus 1 into n, which is nothing but n factorial. Which is nothing but n factorial. Now, if you see this one, 1, 2, 3, so on, n minus r. It is also the product, and you can understand it is a consecutive product of n minus r numbers. It is nothing but n factorial by n minus r factorial. So, understand the formula for a permutation NPR is nothing but n factorial upon n minus r factorial. For our convenience, using the principle of counting, we have derived the formula for NPR as n factorial upon n minus r factorial. This is, understand, without repetition, please. This is without repetition, So, without repetition, n factorial by n minus r factorial, then what should it be with repetition? You can clearly understand, because without repetition, the thing used here should not be used in the second blank place. The thing used here should not be used in the third blank place. The thing used here should not be used in the later blank places. So, that's what you have to understand. So, if the repetition is allowed, what happens? If the repetition is allowed, first blank place can be filled in n different ways. Second also can be filled in n different ways. Third also can be filled in n different ways. All become n only. Then thereby this becomes n, and this also becomes n. This also becomes n, and so on. All the blank places can be filled in how many different ways? n into so on into n. How many n's are there? Rn's are there. So it is nothing but n per r. So what is the conclusion here? It is that nothing but without repetition, NPR is nothing but n factorial upon n minus r factorial. With repetition, it is n power r. So let us write the final formula. Just I have derived this to explain you that this is also based on principle of counting. So, number of permutations without repetition is nothing but NPR. It is also denoted as P of n comma r. And the formula we have just now derived is n factorial upon n minus r factorial. Number of permutations now with repetition is equal to n power r. So understand the difference here with repetition and without repetition. So that's what you can see in the first slide, that is derivation of P of n comma r n factorial upon n minus r factorial. That's what just now I derived it. Arrangements with repetition also, it is n power r. Okay. So next is the number of permutations of n dissimilar things taken not more than r at a time, when each thing may occur any number of times, is n into n power r minus 1 upon n minus 1. What does it mean? Just go through the definition once, just to go through the statement once, rather I can say. The statement here is the number of permutations of n dissimilar things. All the things should be dissimilar. Then you may think, if the things are not dissimilar, what should it be? We'll come to that next. So if n things are dissimilar things taken not more than r at a time, not more than r at a time means you can take one thing, or you can take two things, or you can take three things, or you can take four things, and so on. You have to take maximum of r things, and always remember n is greater than r, of course. Okay. Now, if one thing is taken, it is n power 1. If two things are taken with repetition, n square. Just now we have seen the formula, it is n power r. With repetition, n square, plus three things are taken, it is n cube, and so on. R things are taken, it is n power r. Now, if you take n common, it is 1 plus n square plus so on plus n power r minus 1. You can clearly see that it is a geometric progression. Sum of n terms of GP is nothing but n power r minus 1 upon n minus 1. So, the number of permutations of n dissimilar things taken not more than r at a time. What does it mean? Not more than r at a time means in this case we have taken only 1. In this case we have taken 2. In this case we have taken 3. In this case we have taken r, maximum of r. So, the sum of all these will give you n into n power r minus 1 upon n minus 1. This is sum to n terms of GP. So, you understand that. So, now how many number of functions and others can be defined using this? This is an important thing to be understood. But before that, you must know the definition of a function. Simply, I'll tell you like this. F maps A to B. What is A? You know, A is the domain. What is B? B is the codomain. Okay. Now, the domain is consisting of, let me say, 3 elements, and the codomain is consisting of, let me say, some 5 elements. This is A, this is B, and the mapping F. Let me say, if F is to be a function, then what is the rule to be followed? Then you will better understand a function if you understand what is not a function. What is not a function? If any element of domain, if any element of domain is without association to the set B, then it is not a function. It is not a function. So, understand, every element of domain must have exactly one and only one association with the set B, and this is not a function. That's what I'm explaining. It is not a function. If any element is left without association, then it is not a function. Then it is like this, and it is like this. If any element of domain has more than one association, then also it is not a function. These are the two things you have to remember. You have to remember what is not a function. If any element of domain has more than one association, then it is not a function. If any element is left without association, then also it is not a function. Now, our interest in permutation, using permutation, can we write the number of functions? If F is defined to be a function, can we write the number of functions? Okay. Now, according to the definition of the function, let A and B be two non-empty sets. Let A and B be two non-empty sets. And to every element of set A, exactly one and only one element of set B is associated, then F is said to be a function. This is a better example is if you take your classroom and let us suppose there are totally 30 students in your classroom, and on that day only 25 students are present and 5 students are absent. Then if your teacher comes and calls everybody's name from the attendance register, let us suppose that it as a set A, and if your teacher is calling the attendance, then 5 students will not have any association because they are absent to the class. Then it is not a function. It's not a function. Unlike that, if the teacher comes and he or she is asking your name and she is marking here, that means the number of students present in the class is taken to be set A, and set B is the attendance